We are starting the last chapter we are going to cover this year. The last chapter that we're going to cover this year. And it's going to be over circumference, area, and surface area. So we'll be talking about circles, as I throw a marker. So we'll be talking about circles and other shapes. So we're not just mainly talking about circles, but a good portion of this chapter will be circles and three-dimensional shapes. So what we're talking about first, and what we'll be talking about today, is circumference and arc length. Now the circumference of a circle is, so the circumference of a circle, C is equal to pi d, or C is equal to 2 pi r, where d stands for the diameter and r stands for the radius. And the diameter is equal to twice the radius, or the radius is equal to half the diameter. So if I know one or the other, we can find the circumference. Or if we know the circumference, we can actually find the radius or the diameter. We can go in either direction, just utilizing this equation. So in our first example here, we want to find the circumference of a circle with a radius of 9 centimeters. So for us here, circumference is equal to 2 pi r. And we're going to use the equation 2 pi r because it gave us the radius to start with. So for this here, we're going to have 2 times pi times 9, because we're going to fill in 9 for the radius. Well, 2 times 9 is 18 pi, and if we want to use our units, it'd be 18 pi centimeters. And that'd be the answer, because that'd be the circumference of the circle. The only reason we would give it in something different than this here is if it asks us to round to the nearest tenths, hundredths, thousandth. If it gives us a decimal place that we need to round to, because pi is an irrational number. It's a non-repeating, non-terminating decimal. So we can never actually get the full value of it. But this here would be the circumference of this circle. Any questions on this here? All right, let's look at the next one. The radius of a circle. So this time we want to find the radius of the circle with a circumference of 26 meters. We're still using the same equation. C is equal to 2 pi r. But this time they told us the circumference and not the radius. So we can fill in 26 for the circumference, and we get this here. Now what would we need to do next to solve for the radius? By? We would divide by 2 pi, because 2 pi divided by 2 pi would simplify to just r, is equal to 26 divided by 2 pi is so we can say 13 over pi, because pi would be in the denominator since we're dividing by it. And this one here, or it's approximately 4.13. If we type it in and approximate for the value of pi. Or it could be 4.14 because it's 4.13802.852. So we'd have to approximate this here. Or it's 13 over pi. Any questions on any of this here so far? If we wanted to approximate the one before, this is approximately 56.55 centimeters if we approximate it. If we want to type it into the calculator and get the decimal approximation. Any questions on any of this here? Okay, well, let's look at least 2 more. One where we're finding circumference or diameter, and one where we're finding the radius. So the circumference of a circle with a radius of 11 inches, so again, we're using C is equal to 2 pi r. So if I want to find the circumference, we can use our formula, C is equal to 2 pi r, and plug in the value of the radius, which is 11. 22 pi. If we wanted to put in units, we can put our inches, either 2 marks or, drop that. Okay. Inches. But that would be the answer unless it wants us to put it in decimal form. Any questions on this here so far? All right. This time it wants us to find the radius of the circle with the circumference of 4 millimeters. So circumference is equal to 2 pi r. And our circumference this time is 4, which is equal to 2 pi r. So our next step would be to divide both sides by 2 pi. Now the value of the radius that we would get, well, 4 divided by 2 is 2 over pi. Or if we plug this into the calculator, 0.636. 636. Got them flipped. 0.636. Because I said 0.636, didn't I? And then wrote 363. Flipping it. Any questions on any of this here? Are we good with this here so far? Yes? Okay. So now we're going to look at some where we're finding the diameters. Guys, headphones out. If we want to find the diameter of a circle, or the circumference of a circle with a diameter of 5 inches, we can really use C is equal to pi times the diameter. Pi times the diameter. Now the diameter of the circle is what? 5. So the circumference would be 5 pi. And that's it. And that's all we need to do for this one here. Unless we want to approximate the decimal, it's just 5 pi. Now we can also do the same thing with finding the diameter given the circumference, like we did with radius. Find the diameter of a circle with a circumference of 17 feet. So we're still using C is equal to pi times the diameter. Well, the circumference is 17. So we can plug it in. And then what would we do next? By? So we can say the diameter is equal to 17 over pi. So we have either one of these two answers here. Any questions on finding the circumference or finding the radius or diameter given the circumference? Okay. If we feel comfortable with those, we're going to move on over to arc length. So when we talk about arc length, we're not talking about the entire circumference, but we're talking about the distance along the arc, the distance of it being traveled. Now the circumference is the entire section, the entire circle. And what we can do is we can use the circumference and the arc length, arc measure, to actually find the overall. And part of it is going to be arc length, or arc measure, over 360. Because 360 is the entire circle. An entire circle measures 360 degrees. And if I know what the arc measure in degrees, the arc degree is, and I divide it by 360, we're saying part over the whole. What percentage of the entire circle is this arc? And what we can do is multiply it by 2 pi r, which is just the what? Circumference, to find out what it is. So the arc length is equal to the arc degree over 360 times the circumference, is really what we're looking at if I want to actually find the measure of the arc. So when we look at this here, if I want to find the measure of this arc from A to B, the length of it, what we can say is that our arc length, bless you, is equal to, well, what's the degree measure of this arc? Because 60, this angle is a central angle. The central angle measure is the same as the degree of the arc. Because if it was an inscribed angle, then we would have to multiply it by 2. If the vertex of the angle was on the circle, then we'd have to multiply it by 2. But this here is a central angle, so its measure and the arc's measure in degrees are the same. And this would be over 360, because the part of the circle over the whole. Now we're going to multiply it by its circumference, which would be 2 pi r, and our radius here is 8. So we're just utilizing this formula to be able to find the arc length. Okay, so is all of this here a number? Well, 60 over 360 is a number, yes? 2 pi times 8, that's all numbers. We can just plug this entire thing into the calculator if we wanted to. If we did this by hand, well, 60 over 360, well, those will simplify. 6 goes into 160, or 6 goes into 36 6 times, so that would just simplify to 1/6. 2 times 8 is 16 pi. So if we multiply these together, we would get 16 pi over 6. So 16 pi over 6 would reduce, because we do have a common factor of 2 in the top and bottom, to give us 8 pi over 3. But most likely, if you'd have typed that in the calculator, it would just told you it's 8 pi over 3. So this here is the arc length from A to B. Are there any questions on this here? Any questions over anything we've done so far today? Okay, this time we want to find the arc length of PR, from P to R. So our arc length is equal to the arc's measure over 360 times 2 pi r, because that's what they gave us. They gave us the radius. If they gave us the diameter, we would use pi times diameter. Now, what's the measure of our arc? And the radius is 12. Now, again, at this point here, because everything, all the numbers are on the same side, we have 100 divided by 360 times 2 pi times 12. Well, I could type that entire thing into the calculator, and it would give me my answer. Or if we were doing this by hand, well, 100 over 360 would become 5/18. 2 times 12 is 24 pi. We can do 5 times 24, which is 0, carry the 2, 120 over 18 pi. And this here would give us, I believe, 20 pi over 3. And that'd be our answer. And if it asks for a decimal approximation, or if it asks you to round, it's wanting it in decimal form. And we could just tell the calculator to approximate this to however many decimal places it wants. Any questions on this here? Are you ready for the next one? So this time we want to find the arc length of PQ. We want to find this arc length here. So our arc length is equal to the measure of the arc over 360 times the circumference. So would we continue to use 2 pi r for this here? Did they give us the radius? What did they give us? Okay, so we could use 2 pi r because the radius is equal to half the diameter, yes? So I would take 9 and divide it by 2. What am I going to do once I plug it back into 2 pi r? I'm going to multiply it by 2. Right, so since the circumference is also pi times the diameter, we can say that this is pi times 9. Still talking about the circumference, the same thing. And our arc measure would be and again, just like we did before, we can type this all in to the calculator. Now, if we type this all in, we get what? 15 pi over 8. And that's it. That's all we have to do for this year. Any questions on any of this here? Do we feel comfortable with this here? Okay. Well, now they changed it up a little bit because they're not wanting us to find what the arc length is. They want us to find what? They want us to find the circumference, yes? So our formula that we have is the arc length, which for us here is what? 4.19 is equal to the arc length, or arc measure, which is over times what? Because we'd put 2 pi r, or on the last one you used pi d, yes? But what is 2 pi r or pi d? Well, what is it? It's the circumference, isn't it? So do I need to put 2 pi r here? Well, no. It would help us if we're trying to find the radius, or we can use pi d to find the diameter if we're finding one of those measures. But since we're just trying to find the circumference, we might as well just leave it as c, because that's actually what we're trying to find. So what can we do next? We can do 40 divided by 360, which is 0.1 repeated, or 1/9. It will reduce to 1/9. So what can we do next to get C by itself? By 1/9. We can divide both sides by 1/9. .71. And if we put our units, it would be inches. 37.71 inches. And that's all we need to do for this here. Any questions on this here? Any questions over anything we've done thus far? So let's look at another one. So they told us that the arc length is 6.5 meters. They told us that our arc measure is 130 degrees, and it would be over 360. And we're looking for the circumference again. Now we could simplify 130 over 360. But really we're trying to do what? We're trying to get C by its because we can divide both sides by 130 over 360 because it's going to do the same thing as if we simplified it. Because anything divided by itself is 1. $18 flat. Okay. 18 meters. If we were to include our units. Any questions on any of this here? Do we need to see another example of finding circumference given an arc length? Okay. Let's look at this one here. This one here is a little bit different because what is it asking for? And what indicated measure do we want? RS. So RS, is it going to be, it's going to be in degrees because we're trying to find the arc's measure. Arc's measure is always in degrees. So it's going to be this here. So let's fill in what we know. We know that the arc length is 44. So we're using our formula still. Arc length is equal to the arc degree over 360 times the circumference. So we don't know what the arc measure is, but we do know that it's over times so we're going to need to get x by itself. So we could do either one. So if we can distribute the 2 pi and multiply 15.28 by 2 pi. And it would be over our 360. So 2 times 15.28. And I believe it's, you can check it just to make sure. So if we do 15.28 times 2, I believe we should get 30.56. And I'm going to write it this way here. I'm going to move the x outside. I'm going to move the x over a little bit. Because if we have it on top or if we have it out to the side, it's the exact same thing. Any questions on this here? Mm-hmm. Is anything divided by itself will simplify out and become 1. .98 degrees. Are we surprised that we get a decimal answer? No, because we're dividing by, well, pi is irrational. Just one slight thing. So we need pi. Yep, so that's all that you were missing was pi. Any other questions on this here? So most of this here is just manipulating these formulas to get what we want, yes? So let's look at one more. Let's look at one more of these. So they want us to find the arc measure of JK, the measure of arc JK. So we'd have the arc length is equal to, well, we don't know what the arc measure is, over times 2 pi times 14.32. We can distribute. So we can do 14.32 times 2 pi. So these would cancel, giving us x is equal to. And we can type that whole thing into the calculator. Try it and see what happens. Do we agree with this here? Is that a 2.6? So 84.023. Okay. That seems a little more reasonable. I was thinking 26 looked a little small. Any questions over any of this here? We feel good with this here? Yes? All right. Now we're not trying to find the arc degree, we're trying to find the radius. All right, we're going to go back to the same formula. Well, it'd be helpful if I can actually write. Because our arc length is going to equal the arc degree, which is 150 over times 2 pi r. So really, we're just manipulating this formula to get our answer. And we can multiply those two together, can't we? 150 over 360 times 2 pi. I mean, there's different ways we can manipulate these numbers. Because if I wanted to at this point, I can divide both sides by 2 pi and then divide both sides by 150 over 360. I can multiply those two together and reduce. There's many different ways that we can go about getting r by itself, and that's really the goal. Times the radius, yes? All right, we can divide both sides by 5 pi over 6. Because these would simplify out, leaving us with the radius is equal to. And that's it. Any questions on any of this here? Any questions on anything we've done so far today? We feel good with these here? Yes? All right, let's see what's next. We're not worried about the car tire. The last thing we're going to talk about is this here. Converting between degrees and radians. Degrees and radians. These are the two measures that we actually have for angles, degrees and radians. Radians is a closer measure to what a circle actually is. 360 is a nice number. But if we want to convert from one to the other, or vice versa, if I want to find out what the radian is I can take the degree measure and multiply it by pi over 180. If I want to find out whatever the measure, the angle is in radians, we can multiply our degree measure by pi over 180. If I want to know what the degree measure is, well, I can take the radian measure and multiply it by 180 over pi. So if we're going from degrees to radians, we multiply it by pi over 180. If I'm going from radians to degrees, we multiply it by 180 over pi. So our first one here is we want to convert 45 degrees to radians. So what we'll do is we'll take our 45 degrees and multiply it by pi over 180. And at this point here, I just type that into the calculator. And if we type that in, we should get pi over 4. And that's it. That's all we have to do for this here. Any questions on this here? We want to convert 3 pi over 2 from radians to degrees. So we take 3 pi over 2 and multiply it by 180 over pi. And at this point, we could plug into the calculator to give us our answer, which is 270. If I did this by hand, luckily pi and pi, top and bottom, would simplify. 180 divided by 2 is 90. And 3 times 90 is 270. And that's it. That's all we'd have to do for this here. Any question over either one of these here? Last two that we're going to do for today is just these two here. So we're going to convert 15 degrees to radians. So we would do 15 times what over what? Over 180. And lastly, converting 4 pi over 3 radians to degrees. We multiply it by 180 over pi. Which would just be 240. Now, one of the dead giveaways for radians or degree measure is pi is one dead giveaway if it's in radians. Because if we're talking about a measure of an angle in degrees, we don't normally talk about it in terms of pi. We're not going to say 3 pi degrees. It's going to be 3 pi radians. And also, especially if it's referred to as degrees, it will have the degree marker. If we're talking about an angle, even if it's 6.729 and it does not have that degree marker, most likely you're talking about radians. You're not talking about degrees. But that is all we are going to do for today. Because that is it. I mean, we do have more that we can convert.